Today I'll be talking about embedding Servo, what it exactly means. The goal of Servo is to to empower developers with a lightweight, high-performance alternative for embedding technologies, web technologies in application. We'll take a look today at what that exactly means. Let me just check, can I... okay, like this. All right. Okay, so what are we looking at? So this is basically the classic embedding of a web engine is a web browser. And it really catches your attention, doesn't it? And so you see in the middle we have the green rectangle, which represents web content. So this is the content that is rendered by the web engine. And on top we've got what is called the Chrome, the browser Chrome. So it's things like the back and forward buttons, the address bar, and it's in most web browsers it's a native UI. So you've got kind of two rendering pipelines. You've got the web content and you've got some native UI that is associated with the browser, and then so basically it's a browser that embeds a web engine. But we can also imagine some. Oh, 1 second. Just got to get used a little bit to how the slides work. So we can also imagine some alternatives. So for example, you could have everything could be web content. You could have the browser Chrome could be rendered using the web engine as well. And so there was actually a project back in the days of Servo that was called Browser HTML, which did exactly that. And it was, I think unfortunately it was back in the days of Mozilla and it was cancelled. But I thought it was a very interesting project where basically the whole browser would be rendered with web content. And another alternative is to do everything native. So you can also imagine that you could somehow translate the web content into native widgets, and which is basically what React Native does, at least as I understand it. But back to Servo. So the default embedder of Servo is something called the mini browser, which is what we use at the project when we need to test stuff manually, or even sometimes browse something. And so how does it work? So it's basically it's kind of a classic browser embedding in the sense that we have at the top we have the browser Chrome, which is in Rust, so it's like a native UI using a Rust library called eGUI. And the web content is that's the thing that is rendered by Servo. So basically it's a Rust native UI that embeds Servo. And so the web content actually is the default web content is actually what was just discussed, right, with the layout. So it's essentially the DOM is the in-memory representation of the web page, and every time the DOM changes, layout will compute a display list and then send it to WebRender, which is the graphics component that Servo uses. But it's a little bit complicated, so you see at the bottom there is a couple of other stuff, a couple of other, you could say, alternative rendering pipelines. So for example, if you have a canvas element on the page, there are different types of canvases. So there is, you can have a 2D canvas, WebGL, WebGPU, and each of these uses their own kind of variants of a rendering pipeline. For example, 2D canvas uses a Rust library called Velo. This is new actually, this is quite it's something that was changed recently. But Velo itself uses WGPU internally. And for the WebGPU canvas, Servo uses WGPU as well. WebGL uses a library called Glow, I believe. And also WebRender is kind of involved as well with certain things, but we won't go into the details. And then there's also, for example, if you have images or SVG elements, this is also done separately. But the basic web content goes from like DOM display list to web render. That's kind of a simplification, but it shows it pretty well. Yeah, so this is the, so what does it look like? We can now actually, wait, first I will show this browser in a bit. First, let's have a quick look at the embedding API of Servo. So if you want to embed Servo in your application, what you need to do? So the main API surface is, you've got to build a Servo object, basically, and you do that using a builder. So there's a Servo builder that you can use to configure and then build Servo. And then you can create any number of web views to actually show web content. And both the Servo object and the web views can have delegates associated with them. That's a way to get notifications when something happens, when Servo does something with either for the system as a whole. So the Servo delegate is to get notifications from something happens that isn't related to a web view. And the web view delegate is if you want to get notification and you want to do something when something happens to your web view from Servo internally. There's a couple of other things. So there's a trait called the rendering context, which you need to have one, and you need to pass it to Servo when you build it. There's a couple of variants that are implemented already. There's a window rendering context and an off-screen rendering context. I won't go into the details, but I encourage you to look at the code in the repo, at the examples. And there's something called an event loop waker. Bless you. And there's something called an event loop waker, which you have to pass to Servo as well. And it's a way to, essentially, for Servo to wake up the system event loop in which the context in which Servo runs. So then, let me just move down a little bit. So the basic render loop of Servo, so it could also be like some kind of system event that comes in, but it could also be the event loop waker wake method that is called. And at that point, you have to wake up the system event loop. And one thing you always have to do is, at that point, is you have to call Servo spin event loop. This is for Servo to internally process some events. And as part of this spin the event loop, Servo may call, if necessary, Servo will call WebView delegate notify new frame ready. This is to tell you that you should, for that WebView, you should request a redraw from the system. And when you get the redraw event, or for example, we use, in the default embedding, we use winit. So when winit gives you the redraw event, you should call WebView paint. And in some cases also rendering context present as well. For the off-screen variant, it's a little bit more complicated. I won't go into the details. Again, there are examples in the repo. So that's the basic render loop if you're embedding Servo. And so why should you what's the goal of embedding Servo? It's basically you want to show web content on the screen as part of your application. And probably you want to add some kind of features around Servo. So you want to add something, instead of just showing web content, you also want to have some features around the web content. So it could be user agent, right? The browser is usually referred to as a user agent, but it could really be anything. And we're going to look at a couple of examples of doing just that. So of adding of embedding Servo and adding features around Servo. Så die eigenschappen kun je vangen. Ja, die So first we're going to look at the mini browser that I mentioned earlier. So as you see, it's called a mini browser, and that's exactly what it is. So it's basically a minimalistic browser. And so again, as I just showed, so this is basically web content. The thing at the top, that's a Rust native UI using eGUI. You can see 2 tabs. The address bar, back and forward buttons, things like that. So it's pretty standard. This is what we use internally mainly if you want to if you want to run Servo. Then the second thing I'm going to look is something that I did recently. So we had some discussions about what it would mean to have Servo support mini apps. So mini apps are mostly a Chinese phenomenon where you have an app that is embedded in a native app, and which is currently mostly done in some kind of non-standard way, although it usually uses a web view as well. And so I built a prototype of basically a super app that would use Servo to then to render various mini apps. So we can have a look at this now. So die Ergo-Shipping. So as you see, basically you can install a mini app using a folder on your device. And so this is, for example, to-do list, number one. Then let's install a second one, a calendar app. Again, so these are all basically just web views. The difference with the browser is that you don't load them with a URL, you load them by, as you can see, by installing them, which is done by basically loading a folder locally. But you can imagine that it would come from some kind of... so this is actually a canvas, so this is what I just mentioned. The thing in the middle, so there's HTML around it, but the thing in the middle is a canvas element. So this is actually Velo running in Servo. And right, so this is basically 3 mini apps, running in some kind of Mac OS super app that embeds Servo to render the mini apps, which each of them is just a web view. So my conclusion from this was that it's mostly an embedder thing. So the engine doesn't need to do anything special to support this. It's mostly the embedder that needs to add features. Nou, kan je vangen like a PPT, maat? So then I will show a last demo, which is the last demo is basically implementing an address bar with suggestions. So I'll first go a little bit through the background of this. As you know, almost every browser has some kind of address bar suggestion. So this is, for example, Firefox, right? If I type Servo, I get all kinds of suggestions. And this is actually, so the one from Firefox is actually open source. So I had a look, like, how do they do it? And so there's a repo on GitHub. It's called application services, components, suggest. And here they basically explain that they essentially periodically download data and store it on a local SQL database in your browser. And when you type something, it sends a query to the database, and the suggestions come back with the query. And they say, right, so these suggestions are stored and matched locally, so Mozilla never sees the user search query, so there's some kind of privacy embedded. We can have so this is, for example, the code, right? So query, bunch of, a Rust match, bunch of different providers. For example, fetch Wikipedia suggestions. How do they do it? It's actually a SQL query. So they're, to get the Wikipedia suggestions, you query the local database based on the keyword, and then you get a bunch of suggestions back, and you can show that in the address bar. So what do you do if you don't have a database of keywords and suggestions, right? So maybe you can fake it using an LLM, or rather we could say simulate it. And also to preserve the privacy of users, we can also run the LLM locally. So we're going to have a look at this now. So I built a little prototype of that. So as you see, so I type something, so I type shopping, and you get a bunch of suggestions. Amazon, okay, it's pretty good suggestions for the keyword shopping. But more interestingly, so if you go back on the Servo page, and I type donate, so first I get some general suggestions, but there's also a button so you can get page-specific ones. And it takes a little bit longer, actually. It's a bit slower, especially on my MacBook Air. But eventually, you get some links. So one of them is the actual Open Collective page of Servo, where you can donate money. So yeah, so basically it's a way to get suggestions, and it's running entirely. Oh yeah, there was something at the end. 可以再放一下吗？可以再放一下这个第三个。And at the end, so you see at the bottom here, I also added something like some kind of chat box, because I thought while I'm getting started, I might as well think about what else can I do with an LLM. So you'll see at the end. One moment. So essentially, it works pretty well. And this is an LLM running on my MacBook Air, and it gives you, pretty decent suggestions. And so at the bottom now, I'm gonna 1 second. Here, I'm gonna type goodbye, and what is it gonna do? It's gonna close the browser. So, 那个 PPT 可以再放一下吗？ So how does this actually work? So essentially the core of what you just saw is this. So we saw the Mozilla feature was implemented with a bunch of Rust code, whereas here we just have this essentially. So we have a bunch of English that just says, it explains to the LLM what it should do. And it tells it, you need to return the suggestions in a certain format. And then at the end, it gives, the user input. It might also give the anchor, so basically to get the page-specific suggestions, I give all the links that are on the page, simple as that. So this is, what you call a system prompt, right? So, and it's the system prompt that enables this address bar suggestion. This is it. There's no code that actually does it. And then the second thing that you saw was this, when I typed goodbye and it closed the browser. So this is the prompt for that. So essentially, I came up with only two things. One of them is, so there's two actions that the LLM can decide to take. One of them is nothing. So basically, if you think you don't know what the user wants, just do nothing. Stay in default. And then the other action is close, right? So, and here I explain it. This action should be invoked if you think the user wants to close the browser. And again, you have to define the formats and stuff like that. So this is again what makes it work. At the end, you give the user input. So I think I found this quite interesting because, so this isn't an LLM that generates code, right? It's an LLM that kind of simulates some sort of software component. And the question is, can you actually use it to have an address bar suggestion feature? I don't know, it's kind of slow and it's not very, it's not very predictable, but it kind of works. So at least for a prototype, it's pretty good. And this brings us to the close of this talk. Thank you for your attention.
Thank you very much, Gregory.